Hello, everyone. Welcome to the Envoy intro session. I'm Lizan from Tetrate. I'm one of the Envoy maintainer, and we have Dee also is an Envoy maintainer from Tetrate. He's here. Today, I'm gonna give an intro session to Envoy. I will spend probably half of the time to explain the Envoy, a brief of the history and how it is used, what problem it solves, the configuration model, etc., and spend the rest half time for Q&A. So it's more like Q&A than usual sessions. Okay. Before I begin my session, how many of you guys are using Envoy in your development? In production? Okay, almost none. So how many of you guys have used Envoy in any form? Maybe just hit the Docker run Envoy dev, hit doing a very simple configuration, run Envoy with that. Okay, so it's probably about 10%. Oh, okay. So let me start with what the problem that Envoy was trying to solve. Whoops. It doesn't go through. Okay, so this is basically the problem statement for the microservice networking. So I think if you're running a microservice in the relatively large cluster, you will have this problem. So basically, the networking are handled usually by libraries if you are not using Envoy. So there's different languages that you might use, and there are different frameworks like Finagle, Spring, Ruby on Rails, different language, different frameworks, and different protocol. And you use gRPC, you use database, of course you have the HTTP to handle the external network calls, and there's several different stacks that in your and also you have the infrastructures. Some might be on-prem, some might be on the cloud. You have the different load balancers, F5, ELB, Google Cloud Load Balancer, etc. And the observability output is not consistent anyway. You have stats, tracing, logging, and So the library handles most the different set of the features, but they're not consistently implemented, like the retry or in framework A and framework B will behave differently, and it's hard to debug the stuff anyway. Also, the authentication and authorization is handled by at different point. Like you have the perimeter security in the load balancer in the edge proxy, and you also want to have the service-to-service authentication handled by the framework each service is handled. So those are the problem that Envoy is trying to solve. So unless you are in really big company that have consistent framework managing for every languages, every service in your company, then this will be a very hard situation to solve. And there's the microservice is incredibly painful to upgrade when the library have some security vulnerabilities. So, and the visibility is not consistent. So that's what Envoy is introduced. So basically the very basic concept of Envoy is that the network and the features around network should be really transparent to the application. So what that means is if you do the deployment model have Envoy in the between. Envoy will handle most of the network features you want to use on behalf of your application. So the deployment model here is like if you want to Envoy to handle service-to-service communication, it will be deployed as sidecar, just like this. So this is like service mesh, how service mesh works. Basically, for each application, you have the sidecar proxy that this is like Envoy try to be. And every communication from your service, basically from your application, is going through each sidecar proxy. And that sidecar proxy handles like service discovery, logging, monitoring, tracing, and authentication authorization for you. All you have to do is like configure those sidecar proxy. And we, Envoy also have the unique configuration model that allows you to basically to control those sidecar from the control plane, not like writing the configuration file for each of them. So that will allow you to basically separate those networking configuration from your services. So that's how Envoy started. And also this is like the major designs that Envoy also have. Of course, that I mentioned the service-to-service networking, a sidecar proxy. It also used as edge proxy that that's one of the things we are actively developing also. The use case of edge proxy is emerging as well. So, so the main design goals here is like Envoy is designed to run as out of process, so that it's not a library into your application. It's not, so it can be upgraded independently from your application, your service. And then the code base is a very modern C++ 14 code base that will allow a very high performance. And also, it's a key to achieve low latency, especially for the tail latency in the case. The filter architecture is interesting. We have the L4 filter architecture. Basically, it handles at the TCP currently. We also have in development Quick, which will be like next couple quarters. The L4 architecture allows Envoy to operate in different protocols. So one of the major use cases is, of course, HTTP and HTTP2. But we also support other protocols, like we have Mongo extension, we have MySQL support, we have Redis, we have Double, and etc. Those are like basically the extension point that Envoy can have. So this allows us to basically extend that to different protocols. And basically, the basic TCP proxy can be also used if Envoy doesn't know what the application layer protocols, but the feature will be limited to what Envoy can get from TCP layer, though it can handle the TCP proxy as well. The L4 filter architecture is simple but very strong. There's a lot of extensions for this, like the authorization RBAC, so the HTTP RBAC, like a still mixer, like the API management stuff can be implemented in this layer as well. It is very strong. And also another good thing is that at the time of Envoy being built, the HTTP2 was almost there. So the Envoy was built with HTTP2 first. It has the concept of the all HTTP2 multiplexing stuff that have. So it supports some like HTTP2 based protocol like gRPC from its very beginning. both in the downstream side and upstream side. So HTTP2 is not just for edge. It can also, this also provides efficiency that if your service-to-service call is actually HTTP1, the service, once Envoy handles them, Envoy can upgrade them to HTTP2, which makes the network more efficient. Authentication and authorization is also supported. Mutual TLS is the basic authentication for the service-to-service call, and we have also the HTTP JWT authentication and also RBAC-based authorization as well. So basically, this is like if you use Envoy, Envoy can do this for you. And let's talk a little bit more about the configuration model that I mentioned earlier. Yeah, the configuration model, basically Envoy serves as a universal data plane here. We do have the XDS configuration API model, which stands for the discovery service. So we have, I think I only have two examples here. There's listener discovery service and cluster discovery service, which basically stand for the what's the connection from the downstream and what the upstream is cluster. And we also have the couple more discovery service called like RDS is the route discovery service for the HTTP route, how you map the virtual host path to the which cluster you're routing the traffic to. We have the SDS, which is the secret discovery service that is responsible for delivering key, TLS key and cert and any sensitive information that is separated from the LDS and CDS. The EDS is to basically deliver the endpoint for each clusters. So the configuration API is streaming, and we support gRPC streaming and JSON and YAML, which the schema is defined in Proto 3. So those can be programmatically generated. The central management system controls the fleet, the Envoy, to avoid the per proxy, like you have to configure the proxy for every service or every instance of Envoy. We basically, in the major use cases, the Envoy can be bootstrapped with a very standard bootstrap config for every Envoy. Basically, you just have, okay, here is my control plane server. Envoy should get the rest of the config from this control plane server, and then Envoy can take care by the management server from there. So which is very convenient to do a large-scale deployment. And also, you don't have to do the manual reload or to load the new listeners and load new clusters. The only thing is the control plane server has to push the new configuration to each Envoy, so Envoy will load it a new configuration. So yeah, that's about the configuration. So okay. And here is really brief history. So Envoy started in 2015, and we see a very great adoption from different companies in the industry, and we have been graduated project of CNCF last year. So this is very brief history. I started working after it was open sourced. This is a very incredible adoptions. We now have more than this. This is only a part of the adoption that is published in Envoy website. So we are glad to see more adoption. So this is actually last slide. So I want to spend more time on the Q&A. So Envoy have a great development, a great community. We want to thanks to that, and we have extensibility. So any questions you have, like for any topics around Envoy, you're welcome to just raise your hand. Anyone? Go ahead. Go ahead.
What are the options for a management plan?
Okay. The question is what the options for management plan. There are several solutions out there. I think one is, of course, the Istio, and there are some companies develop different control plane, like Solo have Guru, and DataWire have Ambassador. Basically, there's different options, and also you can build your own control plane. Since control plane is more opinionated, I know some of the big companies just develop their own control plane to connect to their own like service management stuff. In Envoy Proxy project, we do have the basic layer for you to build your like control plane. Like we have the Go control plane and Java control plane, which is basically a generated code from the protocol buffers plus a little bit of plus alpha utilities, and that you can build control plane from there as well. I think that, yeah, go ahead.
Can you raise your hand?
Hi. Do you have any insights? How does it handle like large traffic in terms of users? For example, like million users per month?
Sorry, say again.
How does Envoy handle huge traffic? For example, if it hits 1 million users per month, how do you manage that with Envoy?
So do you mean the edge traffic from outside?
Yes, exactly, the edge traffic.
Okay, so I think, of course you have to deploy like the scale Envoy out to multiple instances as much to handle your traffic. And I think that's like from there, like from big, you have the network load balancer, probably more like low layer load balancer first, and you also can make use like DNS round robin stuff to basically split the traffic out and to each of Envoy instance and down to the each instance levels. Yeah. So I think it's not different how you handle like large scale traffic with HA proxy or Nginx. It's just like that in the same. It operates in the same layer. Okay, I'll hand you next.
Yep. So if I put Envoy in front of an existing service, what do I have to expect in terms of like time that it consumes to process the data that goes through in terms of, I don't know, milliseconds or something?
Sorry, I can't understand what you're saying.
So what additional cost comes into my service calls if I put Envoy in front of a service? How long does it take additionally to what the service already takes?
You're asking about the cost of initial loading, or?
I don't know. If I proxy all my requests through Envoy, what happens? Does it get faster? No, it gets a bit slower. How much?
Yeah. Oh, yeah. So I think in general, generally, like each service to each request going through Envoy, the average latency is lower than 1 millisecond. So, and of course, there's a CPU cost as well. Basically, that is the cost that you're paying for the features that you get from Envoy. Of course, the complicated configuration will cause you more like latency or like CPU cost as well. If you do like external call for the authorization, of course, that add on top of the latency that of the Envoy cost. Here. Okay. This slide is not coming up.
Yeah, so what do you exactly mean by eventually consistent configuration API? Could you please clarify that?
So the eventually consistent configuration API means basically, so we are trying to improve the consistency of the discovery service API. In terms of the eventual consistent means if you use the different set of discovery service API independently, like you have the listener, but you have a listener have a route routed to some cluster, but the cluster is not delivered yet, so that you have to wait till all the configuration pieces needed for the whole configuration be there to serve the given traffic, but the other traffic is not affected. I think yeah, next. Can you let? I think that there's someone already raised hand. Was he still there? Okay, go ahead.
Hello. Just a couple of quick questions. If it is possible to do TLS offload with Envoy, and if it supports different status check from HTTP checks.
So, like the first question is, does Envoy support TLS offload? The short answer is no. We don't do the TLS offload with current implementation. The transport socket which handles the TLS is extensible. We will look into that if someone raises the issue and have the demand for that. Basically, the architecture we can support that. Well, we just don't have the implementation yet. Can you repeat your second question?
It supports different checks from HTTP status checks. If it supports any status check different from HTTP, like custom checks or something similar?
I don't think that is supported right now. D? Do you know? The different than HTTP health checks. Huh?
If it supports, if Envoy supports checks that are not status checks that is not HTTP but any custom checks.
Yeah, we know. Okay, so yeah, basically Envoy support. So check. So yeah, basically Envoy support any upstream. I mean, like health check will be compatible between. So Envoy right now support many things, right? It has like TCP. I mean, like L4 TCP, row TCP. It's also, as Lizan said, we have like upstream in Redis and also in MongoDB. So we have correspondent health check for that. So the health check is one of the extension point. If you have another upstream that speaks different protocol, basically you can create your own health checking. Okay. Yeah. So.
Thank you.
Thank you. Can you name a few other projects that solve the similar problem and compare Envoy with them, like benefits, pros and cons?
Sorry, what project in your mind?
So the project that would solve the same problem and follow the same design as a sidecar to your app. As a sidecar, I think that
which one?
I mean, you must have some competitors in this domain of solving this problem.
Right. I think the service mesh concept is relatively new. We saw some support for the mesh in Nginx as well. So the comparison between them, I really don't have real data for that. But the compared to, if you compare as a proxy compared to Nginx or HA proxy, the dynamic configuration API is really the unique part of Envoy. And the community is a little bit different. In Envoy, we don't have we're not a commercial backed product open source. This is pure community based open source. So the community is different.
Okay, thank you.
Any other questions? Oh, sorry.
Hi, so I have two questions actually. The first one is about the integration with the interface that was announced yesterday at the last keynote, SMI, if I remember correctly. What's the status there and how does it play with XDS? The second question is about plugins, and I mean, as far as I know, you do have the possibility of extending using Lua plugins. What's the status there? Is there a central repository where it's possible to find more plugins and stuff?
So let me go one by one. So about the service mesh interface that I announced yesterday, that is more about how the control plane acts to the comply to the interface. We actually we have formed a new working group in CNCF called UDPA, which is the Universal Data Plane API working group to standardize the API based, the XDS API based on the current Envoy implementation. The SMI is more about how to orchestrate the interface between control planes with the service discovery stuff there. So it is less involving into the data plane here. And probably you can answer the second question.
So correct me if I'm wrong. I mean, so you are asking about the Lua plugins or extensibility of Envoy and stuff like that. So yeah, okay. So yesterday I had a talk with John here about Envoy extensibility. So we have a couple of choices on how we extend Envoy. The first one is, of course, you can write your own C++ extension that will be compiled into your binary. So basically, we have pretty much several extension points inside Envoy itself. The first one is the listener. You can basically design your way to put your own extension in the listener level. So basically, one example is TLS inspector. So basically, you can check the SNI of a connection and something like that. And the common use cases will be HTTP filter. So basically, for example, like gzip or any authentication, external authentication, something like that. So you can do that. Okay, in the way of the methodology on introducing extension to Envoy, the first one is that, C++. The second one will be Lua. Well, the Lua support in Envoy is not that, well, not mature enough, but I think it's sufficient for many use cases. It's there, but mostly only for HTTP. It's not, I mean, currently it's not available for L4 level, TCP levels. And the third one that we want to introduce yesterday, what we introduced yesterday, there is an effort on introducing WebAssembly to basically deal with L4 and L7. It's basically the same thing what you can do in C++, but you do it in WebAssembly instead. So yeah, we're still in a very early in this in this approach, but you can go to the Envoy repository. There is a Envoy-wasm. There is actively developed right now. So I think if you play around right now, you can get the idea of it. It's a very interesting project.
Yeah, and for the extensibility, I will dive more in the deep dive session tomorrow.
Any other question?
Yeah, I'm interested in the case of where where people are using a service mesh together with message brokers. In that case, presumably the mesh won't be able to detect a trace when the traffic is going through the broker. So I'm wondering what solutions are available for people who have that use case, whether they have to implement their own tracing, whether they have to put the tracing libraries in their code in that case, or if there are any alternatives.
Do you want to answer that? Tracing. You have the.
Sorry.
Tracing.
Okay, so tracing is a complicated stuff. So inside to deal with tracing, basically we still have to deal with the application level library. That means you need to basically pass around the headers, the bit3, the headers from the request to the response. I mean, basically you need to propagate the headers. But Envoy itself has trace itself. It supports many several tracing implementation like Zipkin, Jaeger, and any other compatible open tracing mechanism. So you can just configure it to be traced like that.
Yeah, so the limitation here is that Envoy can inspect the incoming requests or like outgoing requests, like each individual request, and add a span that Envoy involved into them. The limitation of the model here is Envoy cannot correlate the incoming request that going into application and the application initiate another request. Then Envoy have no information to correlate those two into same trace context. So that's what application have to do to propagating the incoming one to outgoing one or vice versa.
Yeah, basically you have, like, for example, like you have Envoy in front, and then you have your application in the middle, and then when you do the outbound request, you have Envoy responsible for that as well, right? So in between this, Envoy doesn't know anything about the application logic itself, right? So you basically, the application responsible for making sure that the header is propagated properly.
All right. I think probably I can answer one or two more questions.
Any other questions?
Anyone else?
Well, as a reminder, we have another session, deep dive tomorrow.
Yeah, we have deep dive tomorrow as well, which I'm going to talk more about the extensibility stuff.
Yeah, tomorrow will be more on accessibility and probably forward-looking. I mean, like what we are planning for Envoy.
Yeah, as well. All right. Okay, thank you for coming to the session. Thank you, everyone.